Artificial intelligence is expanding the boundaries of what we can do at the edge. From technologies that transform our health and well-being to solutions that increase factory output, AI is bringing intelligence to the edge and transforming our world. Smart manufacturing is reshaping production, ensuring quality and worker safety by actively monitoring workflows in industries from energy to plastics to textiles. Wearable devices are enhancing our welfare, and AI-driven innovations are increasing the health of our population, young, old, and even our pets. Smart devices now augment efficiency of the workplace, academia, and our day-to-day lives. With Edge AI, we're finding new ways to improve the circular economy, making our world more sustainable. How are the largest technology companies in the world responding to Edge AI? What are the biggest design firms doing to help move their customers forward with the latest technology? And in what ways are companies using AI to help solve some of the biggest challenges facing the planet? Join along and find out how to unlock the limitless possibilities of Edge AI. Welcome to Imagine.
Please welcome Edge Impulse's Chief Executive Officer and co-founder, Zach Shelby.
All right, good morning, everyone, and welcome to Imagine. This is our fourth year putting on the world's coolest Edge AI conference. I'm really proud to host all of you here, where we bring industry leaders together, technologists together, both customers and partners, everyone from across the silicon and AI industry, to talk about something really important. Where are the real applications for AI technology when we hit hardware, right? What are the things that people are really building? And what are the value that customers see out of this technology? So we're customer first, we're developer centric, and that's what we bring to this conference. So we're here at the Computer History Museum, one of my favorite places in Silicon Valley. We host this conference here. Some people have asked us sometimes why we do Computer History Museum. The money we spend here goes to the museum. It's almost like a donation. So this is a really great place to host events. If you have an event, I recommend that you host it here if you can. So Imagine 2024 is going to be about something slightly new. We've talked a lot in the past about technology, new POCs and applications. What are the kind of early adopters of Edge AI? But this market has changed. In the last year, we've seen radical maturity in the market. So now we have a different problem. What happens when customers go to scale? Not 100 devices, not 1,000, hundreds of thousands of devices, millions of devices. We've got some customer cases where they're talking about billions of glucose monitors, billions of devices. So what are the challenges that we hit with Edge AI when we start hitting scale? And the one thing I want all of you to come away with today from this entire conference is inspiration to build your next Edge AI application. Check out the demos, network with each other. We have some of the coolest people in the world here in this room today. And tell me later what you're going to build next. So I talked about the market maturing, and it's very real. For us, we're seeing doubling year on year of the number of logos, the amount of revenue that we see happening, the number of partners that we're working with, right? So I think this statistic is very correct. By 2026, we're going to hit this tipping point in the industry where more than 50% of everything we do on edge compute, right? And I'm not talking about just Edge AI. Everything to do with edge compute, which is massive, will involve some machine learning. And so I think that will be the point where we're in late adoption, right? Everybody's going to be using this technology. This becomes the norm. So how do we get there? With this growth, right, that's putting new pressure on us as executives, as product managers, right, as technology leaders. We're getting pressure to put AI into our products. How do we do that? With this demand, right, this is a question that's in everybody's mind right now in product companies. With the demand for AI in everything, how are we going to productize and scale how are we going to put AI in our products? How are we going to get that to the consumer or to our industrial user? How are we going to show them value, right? So this is the thing that I want to answer today. We're going to dive deep into this and look at the things that are holding customers back from shipping at scale. So for me, there's three major challenges. And you're going to see this in a couple other presentations from keynote speakers today, like Jeff from Capgemini is going to go even deeper in this, working with these customers day in and day out. Three major challenges. How do we generate data? So we do not have enough industry-specific data. We never do, right? We've never seen a single case where a customer comes in and they have all the data that they need to do the specific thing they want to do with AI. So how do we get more data? We've got some very cool things that we're working on to make that happen. We need to production optimize machine learning workloads every single time we have an edge AI case, right? This is not an optional thing. Every single time we do production optimization across hardware. And there is a lot of hardware and embedded. So how do we continue to do this, right? How do we scale production optimization across all the different hardware architectures, all the different goals that we have for customers? We have some cool things we're doing here as well. And then finally, the holy grail for me is deployment at scale, right? Now we go from these POC, 10 devices, 100 devices. How do we go scale this to millions of devices? How are we going to go do the monitoring of these AI solutions? How do we understand what's working and what's not? And then, the most important thing, when we get the data coming back from devices, back to our data sets to improve our models over time, that's when the magic happens, and that's what we call active learning. So what are we doing about deployment and monitoring at scale is the final challenge that we have. Now, this is something that shocked me. Working with a customer, one of our Fortune 500 industrial customers, we were talking about the range of use cases. You know, are we going to build one model that's going to be deployed across all their manufacturing lines? And they're like, no. We figured this out. We have thousands of different cameras on different manufacturing lines on the manufacturing floors. And we need thousands of different models, right? Detecting different problems they've got. And so these guys produce all kinds of safety equipment. So we've got stuff that sticks together. We got stuff that gets glued together. We got things that are malformed. We have things that are malcolored. Every different line has different problems from different angles. So we're seeing this trend towards massive specialization of models, right? It's actually the opposite of what we see from the LLM world, right, with Gen AI, where there's one massive model that solves all the problem. This is telling us that we're seeing the opposite in edge AI, where we need massive specialization, extremely skilled expert knowledge, making its way into models that solve very specific problems. And we have to make this technology so easy in this case that the factory floor technicians can build the model and deploy the model. Not some ML expert with 10 degrees in AI engineering. No, this has to be a technician. So this is one of these holy grails of how do we get here? How do we make this so easy? Now, first we'll talk about generating data. How do we go get this data that we're missing? And the dirty secret from the cloud AI world is that a lot of the AI labeling and data generation in cloud AI is generated with slave labor. So a lot of the people that do labeling of image models and things like that, it is contracted out to Africa, it's contracted out to Southeast Asia, very low wage, clicking buttons to get bounty boxes on things. That's possible with very generic data that humans naturally understand. But we work in industrial applications, we work in energy, we work in oil and gas and mining and healthcare and medical devices. None of the industries that we work in edge AI are going to be applicable for that kind of labor. So we need to be able to generate data in completely new ways that works for the expert models that need to be built. So how are we going to do that? So we have a great example, customer case. So there was a pallet, a stack of pallets in a forklift outside. It was there for a reason, right? That wasn't accidental. Our marketing team has been having a lot of fun with this thing, driving around the parking lot this week. That forklift was there because we had a really interesting customer case that set us down this journey of synthetic data, right? How do we generate data using synthetic means? And in this case, right, we're working with one of the world's leading pallet companies. It's estimated there's about 5 billion pallets in use around the world at the moment. 5 billion. That's one pallet for every 2 people on the planet. These pallets need to be assessed. They need to be identified. Every time they're picked up, we need to know what pallets are there, what's the condition, right? How are they being used? When are they being used? So pallet identification becomes very important. And it turns out for this customer case, we needed to not only do this in real time with stacks of pallets, we needed to do it with battery-powered devices because they needed to be extremely easy to mount and they needed to be easy to put on any kind of equipment. So battery-powered pallet identification was the challenge. And we could not get enough data. Even with our entire solution engineering team, the customer's team, these warehouses are in very remote locations, difficult to get to, expensive to get to. So we could get some data, but not nearly enough to build a real production model. So what do? Well, we started applying synthetic data using Omniverse. So integrating Omniverse deeply within Edge Impulse, we were able to model the warehouse environments, model the different types of pallets, the different types of identification, the condition of the pallets, and blend the real-world data set with the visual, real data coming from the virtual twin of the warehouse. And this really changes the game, right? So now we can generate as much data as we need and then deploy that model not only to, for example, this NVIDIA Jetson-based device for prototyping, but back to the virtual world for testing. So we get this closed loop of model improvement. Then, to get this to a battery-powered state, of course, we can't do that with NVIDIA GPU. To get this to a battery-powered state, we needed to deploy this model down to a Renesas RA8 microcontroller. And we did this successfully by doing some really, really ambitious optimization of the model architecture, optimization of the model data set, everything that we could do to squeeze this onto an MCU. That's 3x reduction in RAM, 8x reduction in flash in order to get this onto the RA8. And we get equivalent performance for what the customer's requirements were. And so doing this with synthetic data, we were able to get this project delivered on time and in budget, which would have been impossible if we had to collect real-world data. So this started to open up our eyes for, wow, what can we do with synthetic data to make this a reality for more customers? So this is an example of what this integration looks like. So we're actually able to integrate deeply with an Omniverse directly into Edge Impulse so that not only we could stream image data into Edge Impulse for labeling and then model training, but we could build a model and move it back into Omniverse and in real time test the model with inference right within the digital twin. So this is a quick example of this. So we have an amazing speaker from Norway. Ivan's going to talk about all the cool things that you can do with Omniverse and Edge Impulse to build AI models, stuff that I didn't even think was possible, a little bit later. So great. We have an official integration now with Omniverse that we've launched that works directly with Edge Impulse. That helps us accelerate use cases. It helps us make data sets much richer, but, and there's a but, Omniverse is only for computer vision, right? We can make very nice looking scenes and we can take pictures of things in Omniverse. But what about sensor data? Sensor data is really the holy grail, right? Most of the applications that we work on with industries involve some type of sensor data. It could be sensor data alone, it could be multimodal, mixed with audio, mixed with computer vision. So how do we deal with these types of sensors? How do we generate synthetic sensor data? I think this is going to change this entire AI industry at the edge. And we're starting to do that with a really ambitious new project. Together with NVIDIA Isaac Sim, with analog sensors, we're building the reference design for using Omniverse integrated with Isaac Sim for physics-based sensor models that we can integrate with any sensor type that then can export data directly into Edge Impulse, the same kind of cool connectors that we built for Omniverse. We can then deploy those models back to the Omniverse environment for testing and additional data generation, or we can deploy them to, for example, ROS for robotics applications. So very cool solution for the robotics space. But we're going to go further than that. Already now we're seeing much broader applications way beyond robotics for this technology. This is a real customer example. It looks silly. We have stickmen falling down in all kinds of different ways. Our team had a lot of fun with this. But this is real. This is a major European elderly home operator and technology provider. We're working with them on helping develop their next generation of fall detection algorithms. Because fall detection is very hard to do. It's very hard to collect the data in a safe way. It's hard to do it in a way that we can plug in different types of IMUs mounted in different ways. And with this technology, we're able to plug that all together. So this is just the beginning. As we implement and publish and launch these features with IsaacSim, we expect this to kind of open up the entire world of sensors to AI. So stay tuned. Another big use of AI we're going to hear later today when Vova speaks from Pentatonic. Pentatonic is an expert in circular economy solutions, recycling and return, redistribution of products from the world's leading brands, Nike, L'Oreal, Lego, Starbucks, you name it. These guys are the experts in this entire field. So they're starting to use, we met them at GTC this year, they're starting to apply Edge AI across that entire chain of return and recycling, from kiosks to the recycling process itself, to the logistics process that goes with the recycled materials back to the consumer again. They're able to apply this technology, and because they're designing these systems for brands, these often don't exist, right? This is where digital twins become super important. For things that don't exist yet, and we need data to develop models and solutions, digital twins let us do that. So we'll hear a lot more from Vova on what they're doing in this space with Edge AI. And notice, I haven't talked about generative AI really yet. What about generative AI for synthetic data? And it has a really important role. We don't think it's the only solution. I think there's going to be a lot of physics-based, digital twin-based models because we can control those. But generative AI is having a big role already for us in the engineering process. So the first place we're using it is, and Jan's going to talk about this in a lot more detail and demonstrate how this works, we're starting to use generative AI for helping our engineers do better work, faster work on Edge Impulse. So AI-assisted labeling, AI-assisted data cleanup, which is very difficult, right? Multimodal data generation, so generating human speech, generating sounds, generating computer vision samples when we already have a beginning of computer vision data set. These are all things that we're starting to do with a whole pluggable infrastructure on Edge Impulse, with everything from OpenAI, 11 Labs, Hugging Face open models. All of this will be possible. So this is something that's going to also turbocharge the space. So we think with synthetic data and generative AI, we can solve a lot of the data problems that customers have as they go to scale. But let's talk about now production optimization. There's no one-size-fits-all hardware in this space. Some people tend to think about this like, wow, we just put a GPU and we solved the problem. But that's not how it works, right? Every single case, every single product needs specialized hardware. So how do we balance that with the business needs, right? We have communication requirements, power requirements, cost requirements for businesses. How do we make those work together so that we can deploy this in a production system? We're going to dive deep into what we're doing with the tooling and the support and the models to make that possible. And I see 5 major things that are driving the need for optimization in these projects. Cost, number 1, the bigger the volume, the bigger the cost pressures for people that are making mass volume products. We're going to talk about a bunch of very cool wearable customer cases later. Power, size. Sometimes these things need to be very small, right? So this Aura ring that I'm wearing, for example, right now, has to be extremely small. A lot of size optimization. Performance and privacy, right? A lot of these things need to stay. The data needs to stay where it is. The stuff needs to stay local because it has to be reliable. A lot of reasons. Now this is challenging, right? These are so many different optimization factors. How do we manage that? Our goal and our mission at Edge Impulse is to match the thousands of different architectures of DSP, machine learning, AI solution architectures with the thousands of different hardware architectures so we can cross-optimize the entire development cycle. We always know how something performs. We always know what an algorithm choice is going to do to your latency, what it's going to do to your RAM and flash usage. Someday, what's it going to do to your power? These are things we want to know as engineers as we're building models. This is a great example of this, right? Even on the best NVIDIA hardware, we still need to do performance optimization. We just don't have unlimited resources. Let's say in a case of quality analysis on a manufacturing line, we might have to be very fast, right? These products might be flying past a camera where we need to optimize for very short latencies. So for example, by applying FOMO and doing some careful optimization, we could achieve 500 frames per second inference rates at 320 by 320. We could go much higher resolution, right? HD if we needed to find very small problems on products and still achieve very good performance. So this is the kind of optimization that's necessary for performance. Or in the case of the battery-powered palette identifier that I showed earlier, we had to optimize for MCU, right? If we want to go battery-powered, we're not going to be running Linux on this device. So we had to optimize for a computer vision on MCU application, and that made big trade-offs with flash and RAM size. Now, some of you might be thinking, well, why do I care about any of that? Because Gen AI is here, right? Very large models are going to magically solve my problem. And we've had some customer and partner cases where people have come to us and been like, all right, I have this very large model in the cloud. It's going to magically solve all of my edge AI problems. I'm just going to throw data at this thing, and it's going to tell me the answer. And that sounds great, except it's expensive to begin with. So we made some calculations with Jan. If you send one image to ChatGPT, to GPT-4 to be specific, one image per second, right? That will cost you $172 per day just to process one image per second. That's 1 frame per second. So absolutely too expensive, right? And too power consumptive. That's a 3-second delay back and forth in order to go process that and get the answer back. So that's not going to work. And then we have another problem with generative AI. It's very general knowledge, right? Gen AI is built on general knowledge of the internet. And that's great for things like human augmentation, right? Helping us label, helping us generate samples of human speech, right, or sounds. Generative AI is great at that. But it's not very good at domain-specific knowledge. So what we really need is the combination of these two, right? The future that we see is that, great, we apply generative AI to the engineering process. We help humans figure out what's going wrong with things like anomaly detection. And then we apply domain-specific models, right? Optimized for performance, optimized for customer-specific data, right? This is about IPR as well. Customers have expert data sets that they need to take advantage of. We can do that with domain-specific models. And we need deterministic performance, right? We need to understand why models work, how they're being engineered, when they don't work, how they're tested, right? Engineers have to approve these things as we ship them to market. So the combination of generative AI, foundation models, and domain-specific models is the future. And we're making this happen by investing heavily on the domain-specific side. So some big things that we've been working on in the last year is FOMO. So a lot of you know FOMO. We've done a lot with object detection on MCUs and made that possible to do about 20x improvement in performance across all target types. So that brings object detection to the MCU space for the first time. FOMO AD, anomaly detection, I'll talk about in a second, and different kinds of very domain-specific algorithmic blocks, like everybody in wearable health, everybody that wants to make a product that uses heart rate, which is in almost every algorithm. So, for example, this Polar watch has these LEDs on the back. That's a PPG sensor. And that PPG sensor needs to be processed into heart rate variability, and 100 different heart rate variability derivatives to do something like sleep or stress or recovery. Lots and lots of companies need this. It's something that's hard to do and fit on a very small device. So we've developed one of the leading algorithms out of the box that can do this. We can plug it into AI development. We're also one of the first to support transformers in our entire tool chain to get transformer-based models not only on MPUs, but on MCUs. And that's opening up a lot of new development in innovative new architectures for SLM. So for example, our partner Sentient recently announced a very cool model that brings natural voice interfaces to embedded devices. So not just turn on, but it's dark in here, right? And not turn up the temperature, but I feel cold. So being able to interpret what somebody intends, not just the command that they give. So that's a great example of where a domain-specific SLM is making its way into this space. And so today we're having two amazing guest speakers, Paul Williamson from ARM will be giving the next keynote. Ekaterina from NVIDIA will be talking about Gen AI and SLMs and LLMs. So we'll hear a lot more from them about what's happening next. Anomaly detection is super interesting for customers. This is actually one of the most critical things that we've had to solve in the sensor world over the last years. So we apply anomaly detection to time series sensor data all the time. Extremely useful, right? We train on the normal data, and then we get an anomaly when something becomes different. But what about computer vision, right? Up till now, computer vision models have required all the data. Every class of not only normal, but every class of failure has to be represented in your model for it to work. What if we could change that? This is one of the biggest problems we see in customers is that they have some vision data, but they only have the normal vision data. What is normal product coming off the manufacturing? What's the normal surface of the material I work with? But they do not have sufficient data for anomalies. So FOMO-AD, for the first time, lets us do this where we can train completely on normal images, let's say surface material. We can deploy to any target, so it's the same FOMO-based architecture, so we can go down to MCUs. And then this algorithm detects these anomalies in real time, localizes them, and tells us how bad they are. Extremely useful for almost every single customer case. So we're going to see this kind of architecture be deployed widely. And then this is when Gen AI comes in. When I say combining the best of these worlds, we can then throw those anomalies to first-line analysis with a very large model to help support teams understand what's going on, right? Rather than them having to look at images in the middle of the night, like what's going on? We have customers in trains, for example, with train wheel anomalies. What's going on with this train wheel? It's an emergency. They can already get a summary of what's going on from the VLM and then shorten their support time and their support load. So lots of innovative stuff happening here. Something else that we're extremely excited about, we're releasing the next generation of YOLO. So a lot of customers need the highest performance. FOMO lets us get the lowest overhead, highest performance on MCUs. YOLO lets us get the highest accuracy. But the problem with most of our foundation models today is that they're trained on garbage from the internet. So YOLO, as we know it today, is trained on COCO, which is basically random pictures of the internet of cats and dogs. Most of them badly labeled, right? So the quality of the data is bad. The data has no relevance to the industrial applications we work in. So for the first time, we're designing a complete YOLO architecture from scratch, training from scratch on real industrial data. And we're launching this now. Please sign up for early access. You can check out this QR code that just went live today and get access to YOLO Pro for the first time. And we're going to be scaling this down for all ranges of MPUs, CPUs, GPUs, as well as high-end MCUs, something like the RA8. So super exciting. For 5 years now, we've been working in this market across the silicon ecosystem. Jan and I came from ARM, so we know this ecosystem extremely well. We appreciate what it takes to build silicon that does amazing things for customers. And we've already enabled the largest ecosystem in the world for doing this. Hundreds of targets, 150,000 developers now on Edge Impulse, and they're developing across 50,000 different companies. So those 150,000 developers, we have 50,000 different companies that they work for. So that's a massive group of people developing these things day in and day out. And they're doing this across all the silicon. So these are just examples of silicon partners that we've announced things with in the last 12 months. In particular, we're doing some really big things with ST. Just had a partner announcement come out with NXP, both on the RT and IMX side. And we have some exciting stuff that we're going to be talking about with Ambic very soon. But this is not it, right? Our silicon ecosystem is growing organically now, right? We're opening up the ability for silicon vendors to go add their own support, publish that into our ecosystem, right? And support all the silicon. And to make that easier, we're now also focusing a lot on silicon IP. So not just the silicon, but the architectures underneath that enable that silicon. So for a long time, we've supported Cortex-M and Cortex-A. We're now working on helium extensions for Cortex to make this even faster on MCUs. And we're doing the first support for Ethos and Ethos U85 that Paul will be talking about today. So we do this not only for the ARM architecture, but we do it for x86. We have RISC-V parts. We have DSPs from several vendors. We have NPUs from almost everyone. We have GPUs from several vendors. So we're committed to supporting all the architectures that we need to build silicon and to build products on. But it doesn't stop there, right? Our goal is to do things like we announced today with Siva, yes, the Neural Pro Nano NPU that just is coming out. We're supporting this fully on the Edge Impulse platform, so people will be able to build silicon to solutions. But beyond that, we're committed to supporting OEMs. So the next phase of Edge Impulse, if you think about it, once we've supported the silicon and the architectures, is supporting the end products. So you're going to see us working more with the Advantecs, the Aeons, the AD-Links, Blues, Particle, and much, much more, so that people can create solutions and not just have to build custom hardware, but create a solution, an AI model, deploy it directly to an out-of-the-box product, and ship it to the field in production. So super exciting. Part of that production challenge, though, is operating systems, right? We're pretty neutral on operating systems. Edge Impulse generates math, so we can run on tons of operating systems. But when we start getting into deployment and things like monitoring, we have to go deeper. So we've done a lot of work already on Zephyr together with Nordic. We're going to be doubling down on Zephyr. So you're going to see us put a lot more effort into Zephyr, make big contributions on how AI is used in Zephyr going forward. We're doing the same on embedded Linux. So new partnership with Wind River that we just announced. We're going to be working together with Wind River on enterprise-grade Linux. You can see a very cool demo in the demo room today. Wind River and NXP together demonstrating Edge Impulse AI workloads in full production. And it doesn't stop there. There's very cool things happening on the Linux side. We just collaborated with Wind River and others to announce the world's next enterprise Linux. CentOS is dying. Elixir is the replacement for this. So Elixir is a new Debian-based enterprise-grade edge Linux operating system distro. And this is exciting because we're going to get fully supported and fully open source enterprise Linux that we can, with confidence, deploy to. Get support, right? Make sure that this is long-term supported for customers. Okay, so we can optimize for these products. We can do it across almost all algorithms, almost all hardware targets. How do we deploy? And this is kind of the final frontier, right? Once you go into lots of devices, this is when stuff gets difficult. So deploying at scale requires monitoring, and this is something that we haven't done in the past from Edge Impulse. We've been deploy, and then it's your problem. We're now launching a new feature called model monitoring. And model monitoring will allow us to build on our partners' deployment infrastructures. We'll have a couple partners in a moment talking about that. And then monitor how models are doing in production. Which models are deployed, right? How many of them are deployed? How are they performing? Where are they failing? And most importantly, how can we get new data from deployed models? Because that new data is what helps us improve these models long term. So again, early access, get this QR code and get on the list. Jan's going to do a cool demonstration later of how this works. To support model monitoring at scale, today we made a new partnership announcement with Zida. We've got Maxi on the stage in the back there. Zida is one of the world leaders in edge orchestration solutions. So this is enterprise-grade, very large-scale deployment of any application workload with visibility and security. So this is an out-of-the-box deployment solution for Docker container type solutions. So this runs on MPUs, not MCUs. With Zida, we're able to then deploy not just to a handful of OEM devices, but they have their own virtualization that's supported on over 100 OEM devices already today. OnLogic, Lanner, Advantech, and much more. So this massively opens up our OEM device support and lets us help customers get this stuff to production in a major way. So Edge Impulse model monitoring together with Zida, we have an enterprise solution end-to-end. But what if you want to build your own IoT infrastructure? To talk about that, I want to welcome Dave up on stage, General Manager of AWS IoT, to dive deeper. Welcome,
Honor
Dave.
to be here.
Thank you. So we're going to talk about building stuff, which I love.
We are going to talk about building stuff.
So to start with, how do you see this bigger IoT and AI picture? What's happening in the market and the architecture that people have to solve?
It's a very interesting time. For a little context, for about the last 15, 20 years, a lot of the energy in IoT went into making the processors, the sensors, the radios smaller and cheaper, making the network protocol scalable to be able to build large networks of these unattended wireless devices. And then making the applications to be able to build the first set of use cases, basic use cases. You can read an electric meter, you can see who's at the door, you can manage a piece of machinery on the manufacturing floor. All good, and we've done that well. But two things have happened more recently to really kind of set the stage for a lot more growth. One is we see these applications moving up to the cloud for lots of good reasons. The scalability, the security, the cost-effective nature of just paying only for what you use. And of course, the access to all of the different applications, as well as all of the different sources of data that you can convolve with this IoT data to start to enable much more complex and interesting use cases. Now combine that with AI, and you now have the tools to be able to do some very, very interesting things. A friend of mine in the audience, you'll see on stage soon, talks about IoT as the nervous system and AI as the brain. And this is where we come to what a great combination I think AWS and Edge Impulse are. We provide that superstructure, the infrastructure, the conveyance to get intelligence to the edge and data back into the cloud. You provide the tools to help builders partition their functionality between the cloud and the edge. And I think that's going to open up a lot of really interesting applications for our builders.
So we've just launched this new IoT Core and IoT Greengrass integration. What is Greengrass, and how does this work together with an AI workload?
Greengrass is an edge runtime that we distribute as open source, typically with Linux, but also with other operating systems. It's essentially our means of distributing intelligence down to the edge, and then orchestrating and managing that intelligence once it's there, and doing so in a cloud-native way. We handle all the networking, all of the security, all of the connectivity back into AWS IoT Core. So it is, again, that sort of conveyor belt of getting AI models, machine learning models down to the edge and managing them through their life cycle, but doing so in a way that's optimized for IoT devices. So you can kind of almost think of it as it's similar to Kubernetes, but for constrained devices, where you can only afford a limited amount of memory and compute time for that function.
So let's talk about the data plane then. So we get models to the edge. Data plane back, right? Most of our customers use AWS and AWS IoT Core for building their data infrastructure. That doesn't go through Edge Impulse, right? We're not a data collection platform. How does that work, and how does that dovetail with model monitoring that we're building?
Well, to your point about this all relies on data, and you can synthesize data. You can also collect it in real time from the real world to be able, again, to not only infuse those applications, but to lead to better training data, training of those models in the cloud. So our mantra here is you infer at the edge, you train in the cloud. And IoT Core not only manages each of the devices as things and makes certain they're secured and provisioned and whatnot, but it also will ingest that telemetry data into the cloud where those models can be retrained, and then you use Greengrass to push that updated model down to the edge. Now, I'd be remiss if I didn't also mention we have another service, Kinesis Video Streams, that's optimized for video data. All the computer vision applications that we talk about, or even ingesting LiDAR data and other things that sense the real world, but in a much more bulk way. These services are intended to be used together as needed, again, to infuse these AI at the edge applications.
And what are the market segments where this type of build architecture is going to be used first, right? Where do you see this taking off?
This is the fun part. Okay. So the way we kind of think about this is what are those hard computing problems that you need to run at the edge, whether it's for security, privacy reasons, cost reasons, or latency reasons. Computer vision's an obvious one. Robotics, as you mentioned, is a great application for AI at the edge. But also more sophisticated security and home monitoring solutions. I'll give you an example. My mother is 93 years old. She lives alone in the 4,500 square foot house my father built for her. Every morning she gets up at 8 a.m., she has a cup of coffee, and she reads the New York Times. If one of those things doesn't happen, I want to know. Yeah. My sister lives a mile and a half away. Now, how do you do that in a way that is intelligent, is private, that can sense what is normal? You talked about the fall sensors. How do you take care of elders and help them to be independent? Energy is another great one. How do you there are models that you can use to disaggregate the signals on your power line and tell you whether your refrigerator is about to go on the fritz. It's a hard problem to run. You probably want to do it at the edge for lots of good latency reasons. Autonomous vehicles. And a vehicle can be a car, it can be a drone, it can be a tractor. All sorts of great use cases where you have unattended things or remote areas where you want to sense and be able to make decisions locally, privately, cost-effectively.
Super exciting use cases for this. So I look forward to what we're going to see customers build. There's a great demo outside that Chad has built. So AWS IoT together with Edge Impulse, we're demonstrating that in the demo room. And another big announcement, you can now use Edge Impulse like an AWS component. So we are ISVA Marketplace.
We love our AWS Marketplace customers.
Yeah, you basically plug us in and we're just part of the AWS bill. Super easy to use Edge Impulse and AWS together. Thank you, Dave.
Thank you, Zach. Honored to be here.
Yeah.
Cheers.
And for some more examples of where this is making a big difference already in industrial intelligence, we have some great customer use cases. One of our major industrial laundry customers is already applying FOMO to real-time detect problems with laundry. And this is commercial industrial laundry. So this is the stuff that comes from your hotel room and gets automatically processed. We can detect even stains that the human eye cannot detect. It's really interesting. Stuff the human eye cannot see, we can pick up, and this is automatically sorted. 100% savings on sorting operations, and just 3 months to production using the technology. Gridware, doing some really interesting work in power line monitoring for US forest fire prevention. It's a $2.9 billion insurance problem at the moment. California has huge problems. And they're using audio and accelerometer sensors with Edge AI mounted on the poles to real-time detect fires and get that signal to authorities, to the utility in real time. So great example of battery-powered optimization. Nextera, we have the founding team of Nextera here. So Nextera is doing incredible work in multimodal lithium battery detection. So using things like computer vision and radar at the same time to detect lithium batteries as they're entering the waste cycle. Or I was just talking with them the other night. We could do this for things like airports when you're checking in your bag. And they ask, sir, did you pack lithium batteries in your bag? They don't know, right? They just trust me that I didn't. Could solve many problems with this. So $15.9 billion problem, existential threat for many waste facilities where these batteries blow up and cause fires. So really looking forward to what this team is building with Edge AI right now. And then GlobalSense. We have GlobalSense CEO and founder here as well. So GlobalSense is doing really cool work in automotive for the detection of safety-based events using audio. So not cameras, not just IMUs, but audio to detect crashes and break-ins. And we have a cool little video of what's happening with the GlobalSense platform.
Introducing our revolutionary solution that enhances traditional trackers with acoustic detection capabilities powered by AI. By detecting sound, the tracker enabled with our AI solution provides a more accurate and reliable way to identify crashes and other dangers.
So a lot of cool things that we're seeing now with multimodal. This is going to be audio, also IMUs, and much more in the future in automobiles. So we're going to see a lot more of this in tracker technology. Now I want to talk a little bit about wearables, right? Wearables are really interesting because unlike industrial, right, we get into massive volumes. So for example, what I showed earlier in PPG, this is a Polar watch, right? Polar produces some of the highest volumes in the world of wearable devices. When those volumes hit millions, right, optimization gets to a completely different level. Now we're talking about not only cost, right, these things need to be very cost efficient, but battery power. So battery power comes extremely important in these devices. So to talk about just how hard this is and how interesting it is to put Edge AI in these types of wearables, we have a very special guest. So I want to welcome Pandu Ranganath, product manager from Nestle Purina, up on stage to talk about pet technology and pet health. Welcome, Pandu.
Thank you.
I also want to welcome Gigi. So Gigi's William's dog. So we had a dog here last year. Thank you, William. Hey, Gigi. Yeah. So we had a dog here last year. Ramses brought his dog, the founder and CEO of Wearables, and that was actually our favorite part of the entire show. We heard from many people. So we wanted to have a dog with us when we talk about pet technology. Yeah, we talk about pet technology. So we're working with Purina on some really interesting projects to bring technology to pets. My daughter wanted to fly our cat all the way from Finland here just for this talk. I said no, but we might have to fix that someday. What's happening with pet tech, right? I'm really interested. This is a market, or what's the business opportunity?
Absolutely. So as you guys know, we love our pets, and pet technology industry is $1 billion space. And it's only growing 10 to 20% every year, right? And the way Purina works is very customer-centric. We do a lot of
We'll turn it up, don't worry. Yep.
How about now?
Better.
Okay.
Yeah.
Sorry about that. Yeah, Purina is very consumer-centric. We do a lot of research to figure out what exactly pet parents want, right? Then we work backwards from there to figure out how to solve those problems with pet technology, right? That's kind of working backwards.
Yep.
That's what we do.
Okay, and how do you see this from a product management point of view? We start talking about edge AI, right, and putting edge AI technology into products. What does that do for you? What are the kind of, features that the consumer and the pet owner is looking for?
Exactly. So, as I said, we all love our pets, so we want to do the best for them, right? But unlike humans, they won't come and tell you what's bothering them, right? So we need to figure out how to kind of get the data from the pets so that we can help them. So that's kind of what we do, and we use AI to do that. Because if you think about it, we have, for example, dogs, right? The various sizes and shapes. The models have to support all of those sizes and shapes.
Yep.
And so we kind of work backwards where we say, okay, what are the consumer problems? What are the pet problems? What kind of data we need to collect from the pets? And what kind of AI models we need to build, right? And then we bring them to the solution.
So let's talk about this Petivity cat tracker, which is interesting. So where's the challenge there when you try to apply AI? What are you having to sense, right? And,
Exactly.
And maybe privacy, too, comes to mind.
Exactly. So with all of the pet products that we're working on, so the number one challenge is, think about it, right? If you have iWatch, you need to collect data, label them, and so forth. With pets, you have a whole new set of challenges. They won't always do what you tell them to do, right? So you need to collect the data from various different sizes of samples, right? It's like all the different dog sizes, for example.
Yeah.
And then labeling is a huge challenge, but we spend a lot of time and effort. We have a lot of scientists and behavioralists to do that.
Yeah.
And then we figure out what kind of AI models will work, and then that's how it works.
And then when you get into the engineering challenges with volume, right? These are very large volume products
Exactly,
that go into all consumers around the world. What does that do from an engineering perspective when you have to integrate AI?
Yeah. Some of the challenges we face is how do we balance the battery power, for example, right? Compared to battery power versus compute. That's one of the challenges that we have. Another one is monitoring the edge AI models. Mm-hmm. How are they working? Because AI is not deterministic, right? You can't really figure out how it's working for them. So that's another challenge that we have.
And I felt bad for dogs. That's why I brought Gigi on stage. So we can expect some technology for dogs in the future as well?
Absolutely, we're working on it.
Okay, awesome. Pandu, thank you for joining me. So Pandu has a talk today in a little while, so we're going to be diving a lot deeper into the realities of pet tech. You can take that with you, and take Gigi as well. Awesome. So it's not only pets that we're tracking with AI technology, but also humans. So very cool new announcement from Ultrahuman, one of the leading ring makers. So we're now deployed in production on the Ultrahuman Ring Air, and we have a raffle today. So at the demo area, in networking, after Jan's keynote, stick around. We've got a raffle off Ultrahuman rings for people. And this is really exciting. We put our new HR-HRV model into production with Ultrahuman in only 2 months. 2 months from starting the project to mass production. And this is really amazing, right? How this cycle of implementation to deployment is happening faster and faster. And that decreased their code size for that part of the algorithm by 40%. And that's a big deal when you're squeezing more algorithms into wearable devices. Ultrahuman also has a new home health product, so monitoring the health of your air at home. All right, test, test. We'll use this now. Monitoring the health of the air in your home. So this new Kickstarter project, check it out. You can buy one of these yourself. We're going to be working on this with Edge Impulse as well. Now, this stuff gets tricky when you do low power. And to talk about low power, I want to invite Scott Hansen, founder and CTO of Ambic, up on the stage.
Thank you.
Power's crazy in these devices. So the conversations we've had with customers on just how much we need to squeeze out of these devices when they're on all the time,
Yep.
monitoring humans, is really incredible. And you've done super smart things with Ambic in this space. Tell us what the reality is around AI, which is consuming some data centers and power plants. Microsoft recently tried to buy a nuclear power plant. Said it. Power plants worth of energy to run AI, and now we have to do it on a tiny battery.
Yeah. No, it's a big problem. You're in the cloud, you've got gigahertz, you've got gigabytes. Most importantly, you have kilowatts, right? At the edge, we have none of that. We are incredibly constrained, and actually, let me quantify it for you. So I did some math before I came here. Your typical wearable customer might have a 50 milliamp hour battery. Imagine that you're building a wearable, you want that to last for 7 days. Do the math, you'll turn out, you got to be at about 1.1 milliwatt average power, which to me sounds like a tremendous amount of power, by the way. Okay, it sounds like a lot. Many of you are looking at that thinking, wow, it's tiny. But actually, that's not what we have available for inference, right? That's what you've got available for UI, for graphics, for sensors, for security, for communications. And then there's a little sliver left over at the end for inference, right? So actually, let's say we give ourselves 10% of that power budget for our wearable device here. You're looking at 100 microwatts for inference, right? That's a difficult problem. And actually, that's the problem that I founded Ambic to solve.
So how does that work, right? I mean, I came from ARM, where we're working with low power all the time. Why isn't Cortex-M on standard processes good enough, right?
Yeah. Well, we'll let Paul talk later about why the Cortex-M is a wonderful solution for everywhere. But what Ambic does uniquely is, first of all, we build the world's most energy-efficient chips. We've shipped more than 250 million of them. They're ARM-based devices with little GPUs and memories and all sorts of other things. And we are between 3 and 10 times more energy efficient than the competition through use of a technology that we call sub-threshold or near-threshold operation. And we've got a marketing version of that called sub-threshold power-optimized technology, SPOT. I'm not going to get into, that's a whole other discussion we can have another day. I'm not going to get into the specifics, but the basics are we're running at a much lower voltage than you typically operate transistors at. Energy is voltage squared, so as we drop that voltage, we're getting huge energy savings. And so what does that mean for all these developers out here? Maybe it means longer battery life, but frankly, my guess is most of these attendees here are not thinking about that. They're thinking about how can I bring AI where there was none before? And 3 to 10 times energy advantage means 3 to 10 times bigger AI models. It means I can put 3 to 10 times more compute in the same energy envelope, and that's a flexibility that's pretty incredible.
Right, so lower power doesn't necessarily mean less compute. It might mean more compute per watt, right? Yeah. So we can do more AI.
Exactly.
This is exciting, and we started working together on the Apollo 510, which brings in acceleration. So what do you see acceleration for AI enabling at this kind of low power threshold of what you're working on with customer?
Yeah, I mean, first of all, there is a place for that. I think the Apollo 5 is based on the Cortex-M55. You have a helium vector unit. You can run 8 max per cycle, and that's luxurious for most of our customers, right? I'm going to say that probably 75% of the applications that we see at customers don't need an NPU, maybe don't even need that vector accelerator. Actually, you can do a lot on a very small amount of compute. So actually, it's worth bringing up a couple of our customers who are doing this today. So we today are serving many different wearables customers. We're talking about wearables right now. If you were to go to Best Buy and walk down the aisles of there, you'd see our chip in devices like Garmin and Fitbit, Google, Huawei, Xiaomi, all sorts of companies I can't name. But what we're seeing is a migration toward more medical-oriented devices, right? So these are devices that look like wearables, right? They might look literally like this thing I'm wearing, but they're for a clinical setting, right? They're sitting there on a patient in a hospital or a patient who's gone home. And one of the customers that I'll bring up is a company called BioStrap. So really cool company that has built a device that looks very much like the wearables that you see everywhere else. What they've done is they've taken our Apollo 4 based device and built a bunch of neural networks on top of that. And they've done so for all sorts of what I call small AI reasons, right? So what I mean by that is in small AI, you're taking a traditional algorithm, traditional filter, whatever, and you're replacing it with a neural network. You're doing the same thing you did before, you're just doing it better with higher accuracy, right? And this is actually the vast majority of what we're seeing at customers is exactly this, right? So back to your comment on LLMs and all that stuff, this is the kind of thing people are building. And in BioStrap's case, they are using models to detect the onset of sleep, to detect when sleep is finished, for heart arrhythmia detection. These are all really exciting things that they could do before without a neural network, but they're doing it much better now. What's cool is they're using Apollo 4. This is a maximum 200 megahertz processor with a couple megabytes of memory and a handful of other resources. So this is not, there's no NPU, there's no need for an NPU, right? I mean, in this particular use case, there's no need for expensive memories and all that. This is a very well optimized set of models that fit on a small processor. Another customer that I'll bring up, this is not a wearable, but I like to think of this like a Fitbit for industrial machine equipment. You already talked about anomaly detection earlier, but we have a customer called Shoreline AI that has a edge-to-cloud solution where they're taking little battery-powered devices that they put on industrial machines, monitor the health, look at vibration signature, sound signature, and then flag when there's a problem that's imminent. And again, what's exciting here is they're actually using an even smaller processor. They're using the Apollo 3 generation, which was launched back in 2018. This is a Cortex M4. It's got, again, 1 or 2 megabytes of memory. It's got no particular acceleration, but it is incredibly energy efficient, right? So you combine all that together, you add in a good software stack, and we've got a case where edge AI is suddenly feasible. You don't need to worry about the gigabytes and the gigahertz and the kilowatts. Suddenly we can build right-size 100 microwatt models that are suitable for the edge.
So for me, the holy grail feels like, how do we squeeze more algorithm into the silicon at an MCU level?
Yeah, absolutely.
Yeah.
Absolutely.
Awesome. So we've got a demo of the Apollo 5 with that gem pulse running out there. It's very cool.
Yeah.
I want everybody to go check it out. And please, if you want to talk about low power, come find Scott during Imagine today and nerd out.
Awesome. Thank you.
Scott. So speaking of low power and high volume, we've got some really exciting products to announce. HP Poly, we talked about last year when they were enabling keyword spotting models on advanced wearables. Well, those wearables are now in mass production and you can buy them. So the Voyager 60 headset, very cool looking enterprise grade headset, now includes 10 different languages of keyword spotting models. You can tell this thing to answer, to ignore calls in real time. This is running a Qualcomm chipset. And they have the same functionality in earbuds. And if I can open the case, what I love about these earbuds is that the case has a touch screen. So my AirPods, I always open this thing up and try to get my phone to tell me how much battery is left. You've all done that before. Half the time it doesn't work. This has a screen built in, so it tells you exactly how much battery is on the earbuds anytime that you want. So 2 very cool products powered by a gem pulse. You can buy these right now. And just today, we have another product announcement from a partner that was on stage last year at Imagine, Ramses, who demonstrated a very cool demo of an AI-enabled EEG headset. That was a prototype at the time. And they're able to detect cognitive fatigue. When are you too tired to work, right? When is your cognitive skill declining because you are too fatigued? And this is important for people like medical professionals, pilots, right? People that need to be awake and best at their job. And very cool, Neurable's now gone into full production launch today with Master and Dynamic MW75 headset. This was just picked up by CNN, which called it Fitbit for your brain. So I love Scott's Fitbit for your machines. Fitbit for your brain. So you can buy this for $700 and understand your brain health, cognitive fatigue, and even it's being used for things like treating depression in several countries to start with. So super inspiring story. I hope some of the cases that we had on stage this year, next year, hit this kind of success. And to wrap up, what's the future of Edge AI, right? What are we going to see to make people successful? And for me, it is these three things, right? We need to empower developers with the tools to get the data that they need to build cool models, right? That's the biggest gap that we've got in the whole industry. And we're doing that with a mix of synthetic data sources with the likes of Omniverse and Isaac Sim integrations and generative AI to build millions of domain-specific models. So this is happening right now, and it's exciting. Two, we have to continue to do this type of production optimization. So the customers that Scott just brought up, right? They need to squeeze more algorithms into these small devices. A watch like this can run dozens, if not hundreds of different algorithms, right? These things have massive numbers of algorithms they have to squeeze in. So how can we squeeze in more algorithms for the silicon that we have, for the power that we have? And then finally, when we talk about deployment, it's not just Edge Impulse, right? We're an ecosystem player, right? When we work on a customer case, it's always with partners. And together, we have the ability to go solve any problem on any silicon, with any class of algorithm, with any data. We have the talent here to go solve problems. So please come talk to us at Imagine or after.